the UNC professor, so do the same explanation. And also, if you have any question, you can ask. And if you have any question, you can ask me. So I answer your question. Okay. So if you check my email, check my announcement, you will have a link, right? In that link, there's a video. So if you can watch that video, follow that video. So the first step for the lab of number one, homework number one is how to submit a request to get data. Okay, so this is the first assignment. Actually, if you can follow the video step by step, it's very straightforward. It's easy to do that. And at the end, we start to see the image. So then we talk about how to analyze this image. So the first lab is two parts. The first one is how to submit a request online. So the second part is how to make analysis. That's it. So yeah, so I think we can answer all the questions. And also, Jacob here helped me to answer the question also, and he is serving as a TA. So he can help you guys step by step to do your homework, okay, on Webassign homework. And also my understanding is this, okay, if you try your homework, if the answer is not very accurate, I still can accept, okay, I still can give you credit. And if you already have a Webassign account, as I told you before, I give you 5% extra bonus. So technically, all of you already received 5%. I will post that bonus online. Okay. So then you follow the tutorials and also follow the video step by step. So try your best. Okay. I understand somebody still cannot follow. Maybe somebody posts a wrong answer. It doesn't matter. Okay. If you try, I will give you guys credit. Okay, so this is the purpose for this. Webassign homework is the help you to using remote telescope and how to do the analysis. And this is the foundation for astronomy, right? So right now have all the information online. We have all the telescopes on the wall. They make the network. So if you know how to do that, how to submit a request, how to do analysis, you can do the astronomy by yourself. So that's the reason why we added this one. This project is live in this course. So this is the purpose. So because some of you email me, ask me questions. So why you needed this Webassign assignments? So this is the power. This is the reason. Okay. So do you guys have any questions or? Rob, I already set up the account for you, okay?
Okay, no problem. You said you set it up yesterday, right?
Yeah, exactly. So if you can follow the procedures and then submit a request, that's good enough. Then waiting for 3 or 5 days. When the data come back, so then you follow tutorials to do the analysis. For example, how to measure, so the planets, and how to measure those things, right? The size, whatever, but also determine what the location is. If you type in a number, if your answer are not very accurate, don't worry. Okay, I will take care of that. But first step is you submit the request. Okay, first, and also in the Webassign there's several planets. I think if you can do one of them, for example, if you can follow the video tutorial just to do the Jupiter, okay, that's good enough. So this will help you to how to get a remote data and how to use software, okay. So if you just focus on Jupiter, because we can observe Jupiter, right? So based on the tutorial, so you just submit, oh, I need an image for Jupiter, okay. So just waiting for 3-5 days. When the image come back, so they follow the tutorial videos and do the analysis. So this is lab number 1. So I hope everybody can do something, and also everybody can do something is good enough. Does anybody have any other questions? We can talk online on Zoom, right?
I have a question.
Okay.
Okay, so I'm not really like it's not really clear what you said just now, but is it possible for you to like take us through step by step, like share your screen and show us like how to access Webassign and like where the assignments are supposed to be? Because I think the problem is people don't know how to use it at all. Like we don't know it, we've never used it before, so it's like we all trying to figure this out right now, and it's not really the best time for us to be figuring it out.
Okay, so the first of all, can you log in the Webassign? Can you or
Yep.
cannot?
Dr.
Right,
I'm happy to show all this whenever you're ready. I'm happy to show Webassign today, Skynet, answer questions. Not to interrupt, but
can you show it to us, like split your screen so that we can see it visually as you going along versus just him calling it out, please?
oh yeah, I will once Dr. John gives me the go ahead.
Okay.
You just go ahead. Just go ahead, okay? Just go ahead.
Mama,
Okay.
what in the hell is going on?
Well, let's see. Should I begin, Dr. Zhang?
Could you repeat your question?
Oh, me? Should I begin?
Yeah.
Okay. So, hi everyone. I'm Dan Reichert. I'm director of the Skynet Telescope Network. I'm over at UNC, and Dr. Zhang and I work with a number of institutions. Some of them doing research with the telescopes, and some of them are educational partners. Dr. Zhang's one of my educational partners, so we're trying the labs out with you all. It's a unique experience. We have these robotic telescopes, fully automated, all around the world. They do cutting-edge research, but they've been used by about 50,000 students as well, all ages right down to the middle school and even elementary school level. So once you get used to the interface, it shouldn't be that hard to do. Anyway, I see a bunch of blank boxes, and you don't have to turn your camera on, but I would love to see who I'm talking to. It's always good to get some facial feedback, right? So I'm talking to black boxes. I don't know if you're excited and happy or if you're like, oh no, this is horrible. But if anyone does want to share the video, you're welcome to. I appreciate it.
I just got out of bed and I looked a mess, so you're gonna be talking to this box today.
But I understand,
I just got out of bed too.
I'm wearing my shirt and tie, but it's just sweatpants down below. So all right. So let me show you something. We'll begin with Webassign. I'll share my screen. Now let's see. And I am recording, so if anyone misses the class today, yeah, I see some people are asleep. You still in bed? That's fine. If anyone misses the class today, we'll make the recording available. Let's see. Share my screen.
Follow me on TikTok.
Okay, so now that I've shared my screen, this is not the screen I wanted to share.
Are you able to send a recording to him so he could put it on Canvas?
I'll dump it on YouTube, and I'll send the link along.
Okay, thank you.
Sure. Let's see. That's not the right page. Yeah, I've been spending my last week modeling COVID-19. I have a website for that. That's what this is. So that's not why we're here today.
I'll have to ask you about where you're pulling your ratios from.
Yeah, it's well, different topic. We can talk about all that. It's cool stuff.
Hey, quick question. So
Sure.
this little Webassign thing, this is homework, basically, like homework, classwork for us, or it's like.
But that's up to Dr. Zhang. So,
Yeah, that's what I'm asking.
Yeah.
Yeah, this is the homework. Yes, homework.
It's homework? Okay.
Yeah.
All right.
But it's not going to be your usual homework, where you work some problems and turn it in. This is a different experience. We're giving you access to the same telescopes that professionals are using to do cutting-edge research. You'll be using it right alongside them, using the same interface. And the instructions are given out in Webassign. So let me back out of one of these Webassign tabs. I saw most of you have a Webassign account. I think most of you have gotten that far. Let me go to the main page just in case you haven't. So Webassign is kind of like the publisher. They own these labs. I wrote the labs, but they own them. And they did a good job putting them together to make them easy to use and access. Think of it as like an interactive textbook that teaches you how to use these labs. Anyway, the front page is here. You just go to webassign.net, and you all have a class key. And Dr. Zhang, you've passed that around, haven't you?
Yes.
Okay. Yeah, I don't have it off the top of my head, but you know, if you haven't done it yet, you start there, enroll with the class key, and you type in whatever it happens to be, and it's like a number and another number, and you go to the enroll. In fact, I can pull it up for your class. I'm sure I have it here. Oh, maybe not. Anyway, you type it in, and then it's a pretty standard enrollment procedure. You go in there, you create a user account, like a username and a password and things like that. And also then they're gonna ask you to pay for it, right? Because it is a textbook company, and so there are access cards at your bookstore. Anyway, that's all on your side. You know, Dr. Zhang has told you about that. But once you get in there, it will look something like this. This is the student view. And you probably only have one course option. I'm in a zillion different courses here, and I'm a guest in your course, so let me click on that. So once you select your course, it'll look something like this. And here you'll see the various labs. Lab 1 is currently due April 7th, but it's really a 2-week lab, and we'll see how it goes. And maybe Dr. Zhang will push the due date back a little bit, but this is not something you can do at the last minute. You know, these are real telescopes under real conditions. Some nights the sky's cloudy, so if you wait till last minute to put your observations in, you may not get them. And we have the extra problem of COVID-19. I have about 20 telescopes distributed around the world: Chile, Australia, Canada, the US, Poland, and other ones coming up in other places. But a lot of them are shut down now, even though they're fully automated. These telescopes are robots. They're fully automated. They have to be shut down because if something does break, a human needs to go there. And a lot of these places are under travel restrictions now. So we've had to shut the observatories down, including my best ones. I have a cluster in the Chilean Andes. It's at the US National Observatory in the Southern Hemisphere. Those are our best telescopes. Those are the ones you would be using. And the whole place is shut down because of COVID. And my next best telescopes are in Australia, and they just closed down a couple days ago. So we're kind of using whatever scraps are left on the system, and we'll see how it goes. It's going to be slower going getting our data back. It's just this unique circumstance that we're all in. Everything is inconvenient these days. So we'll see how it goes, and I'm sure Dr. Zhang would be lenient if we're having a hard time getting telescopes to complete the observations just because there's so few of them left. Okay, but we'll get to the Skynet side in a second. So when you're here, you can go to lab just by clicking on it. And then there's some instructions here at the top. I'll walk you through that in a second. And then you see the lab. We have week 1 here and week 2 here. Let me just close that. It's an accordion kind of structure. So you can open up any particular piece and look at it and close it so it doesn't get too big and all over the place. So don't worry about this. Week 2 is analyzing the data you get back. Week 1 is just learning how to use the system, put in some observations. We're going to take some pictures, some solar system pictures, some pictures of things far away in the universe. And it's pretty cool. Just from your laptop, you can type in a few things, and a telescope somewhere else in the world will respond to your commands and get that image back. It doesn't happen in real time. It's a queue system. You put in the queue, and then Skynet, which is the brain of the system, named from the Terminator movie. That was the program that became self-aware and took over the world, as the reference. Skynet will decide when to dispatch your observations. Okay, so let's just walk through this a little bit, and then I'll pop over into Skynet, and we'll work on Skynet, log in, make sure everyone has their account, and how to use it. Okay, up here, the goals of the lab. And I'm not going to read through the whole thing for you. You can do that. Actually, let me pop up here to the instructions. So all the labs begin with kind of the same instructions. There's some videos here, and normally it's just one video. It's of one of my TAs teaching the lab at UNC. Since this is the first one, there are a handful of them. They're kind of old, and I've been shooting some new videos, and I've attached them down here. And so down in the lab, there are links to video tutorials, and instead of using those, use these. They're brand new. They work with, we're always updating our software, so this is up to date. And the first 3 ones are connected to the first week of the lab. So this is the kind of stuff I'm going to cover today, but you can see it in more detail by clicking on these 3 links. Otherwise, it's just general stuff. How many times you can submit, warnings to save your work periodically, because if you don't, Webassign will time you out. Don't have 2 Webassign tabs open at the same time. That can cause conflicts. How to enter different things. Anything in bold, I'd read that. Just make sure that you know how to avoid a critical error. Okay, so that's what's at the top, just general instructions on using Webassign, and then the links to the videos I've been shooting for you. Okay, now down into the tabs here, the goals. First goal is just learn how to use the system, how to observe with their telescopes. It says in Chile and Australia, those are closed down. There's still one Australia telescope, but other telescopes around the world. There are telescopes that we build here at UNC and deploy. Then there are other people who just come to us. They say, hey, I have a campus observatory. Can you hook it up to your system? And the answer is usually yes. Well, there's all sorts of different telescopes on here. The other 3 goals are how to analyze your data. And that's going to be next week's stuff. How to adjust the brightness and contrast, to view details in your pictures, how to measure angles in your pictures, how to identify moving objects in your pictures. But right now, let's just learn how to put observations in the system. And there's a tab telling you what you need for this lab. For this, you just need an internet connection. And then we have a couple background sections to tell you a little bit about the system, and then the procedure. The procedure is going to observe some planets, observe some moons, some dwarf planets, some deep sky objects. Background, the first one just tells you a little bit about my prompt telescopes, which are the UNC highest quality, most reliable telescopes. And here's a picture from our site in the Chilean Andes. All these telescopes are ones that we built, and you can see, if you're there, this is what the Milky Way looks like at night. If you've ever, you can see it kind of like this here in the US. You just got to get to a dark site away from the city with the moon down. Give your eyes about 15 minutes to adjust and look up. You'll see that. If you've never seen it before, it's maybe worth going out and trying to do. It's pretty impressive. But from this observatory in Chile, it's like better than I've ever seen before. It's one of the best sites in the world, and you all have access to it. Well, you did until COVID-19 struck. But we have other telescopes as well. This is one of our clusters in Australia. Maybe I'll just show you a little thing about how these robotic telescopes work. So again, this is my main cluster in Chile. When the sun is 1 degree below the horizon every night, the domes open automatically. No one's there. There's a person walking in the background, but he's unrelated. And there you can see the telescopes. They're good size. They're bigger than this. The mirrors are about 16 inches to 24 inches in diameter. That's the mirror. The tube's usually twice the size of the mirror. And so you have access to these things. Close that down. And actually, this one's kind of fun. You could play with this on your own. This is a live webcam of the site. Again, we're not going to be using these telescopes because of COVID, unless things get better in Chile and they open them back up for us. But many of the other sites are just like this site, or similar to this site. Let me zoom out and give you an idea. So here we are high up in the Chilean Andes. This is a live webcam, so you can go to this link at any time and poke around, and it's linked there in the lab. So you saw some telescopes there, and then down here we have some buildings where people eat and stay. Last time I was there, it was a long time ago. I don't usually go anymore. I send people. But I went there for breakfast, and there's a tarantula crawling across the floor. And because you're really out there. You check your bed for scorpions and things like that. I'll just show you one other thing's kind of cool. One mountain away, I don't know if it's clear enough, but we'll see. If we zoom in, I think I got the wrong mountain. Let me zoom out again. It's a 2-mountain observatory, and there are telescopes on the other mountain as well. Oh, here it is. It's this mountain. And these telescopes are not part of Skynet. These are big telescopes. This one has a mirror that's 4 meters across. The one over to the right has a mirror that's 8 meters across. We don't have access to those. Those are still run by people. But the Skynet telescopes are smaller and computer automated. So anyway, those are just some fun links that you can play with to get excited about these resources. And continuing on, here's a section talking about why we built the telescopes in the first place. We're looking for distant cosmic explosions. And back in 2005, we actually used one of these telescopes to find the most distant explosion in the universe. Again, these are the sorts of telescopes you'll have access to. This is some basics about how a telescope works. Now here's me standing next to one for scale, also to make it look cool. And the light, it comes in from the top, it bounces off a mirror in the back, comes off, bounces off a secondary mirror, then down through a tube here into your filter wheel and your camera. Now, these cameras are kind of special. They're super sensitive. They're same kind of technology that's in your phone, except just to give you an idea, your phone has millions of pixels. And I forget, like, how many megapixels is a phone? 8, 9, 10, 20 megapixels? These are typically 1 to 4 megapixels. But a 1 megapixel astronomical camera, it's like $10,000 bucks. And so these pixels are much more expensive because, well, they can see in the dark, and your iPhone cameras can't. Another aspect of these astronomical cameras, they only take black and white pictures. So what we do is we have this kind of wheel of different colored glass between the telescope and the camera. And if you want to observe in like R band, that means I'll be looking in red light, you'll learn how to select that. It puts the red filter in place, and then you take a black and white picture of red light. You can take a black and white picture of blue light. You can put these together after the fact if you want to make a color picture. But that's how astronomers make color pictures. We gotta take red, green, blue separately. And there are other options as well. Things redder than the human eye can see and bluer than the human eye can see that you can still take pictures of. Okay, then there's some other sections about how we maintain the telescopes and some of the other scopes on the network. Not too important. Let's hop right to the procedure. Though I can pause for a second if there are any questions. Okay?
No, you did.
All right.
So you're saying that we have to go through all of these little dots, and then, but what is it doing to record our homework?
Right.
Really?
The nice thing is, well, in the first week, you don't submit anything here, but let's just pop down to week 2 here. So your images, you'll submit them right into this lab. Like here, you upload your files. There'll be little question boxes where you can describe details in your images.
So we're uploading a picture of.
So I'm sorry to cut you off, Hannah, but where I'm confused. Where exactly are we getting these pictures?
I'll show you in just a second. It'll be Skynet. So Webassign is the lab manual. It's interactive. It tells you what to do, and it's also where you're going to put your results. But you're going to use Skynet to get everything. Now I'll pop over to that in a second.
So we're just going to be copying the pictures of the planets.
Yeah, from Skynet, you'll request it, and then you go to the Skynet site to get it back once it's taken a picture for you. It's not an archive. It's not going to go find some picture that was taken a long time ago. It will take control of the telescope and take a picture just for you. And then you will upload it. You download it from Skynet and upload it into Webassign. and answer questions and measure things from the images. And we'll learn how to do that over the next 2 weeks. But back up here, so now into the procedure. The first one is how to observe a Skynet. There's a link to a video, but it's old. We're in the process of updating these labs. So for these video tutorials, I would not use those. I'd go right up to the top and start going through these. The first 3 are relevant for week 1. So the first one is how to submit an optical observation to Skynet. Click on that, brings up a YouTube video. All right, I'm Dan Reichert, of this handsome looking guy who's gonna walk you through it. But I'll give you a short version today, and then you can always go to this video tutorial for detailed instructions. And also it's written out in the lab as well, so multiple ways to figure this out. But let's go to Skynet, and I'll show you how to put an observation in. Well, first, if you go to skynet.unc.edu, that takes you to the front page. And I'm logged out at the logged in at the moment. I'll log out, so it's just like when you're getting ready to log in.
Will we be provided with the login for Afterglow and Skynet?
Yes, Skynet and Afterglow use the same login, and you all should have received an email. If you added to Webassign, more than a few days ago, I grabbed those email addresses, and you received an email from Skynet.unc.edu with registration instructions. It has a registration key. And some of you added more recently, and Dr. Zhang and I have added those as of last night. And if you haven't gotten into Webassign yet, you'll want to email one of us, and we'll create your Skynet account for you then. But if you've been in Webassign for at least a day or two now, you have received an email from Skynet telling you how to register. And I'm trying to remember what it is. I think it's, no, it's not that. See, I never, once you create your account for the first time, then you'll be able to log in using your username and your password that you'll set. So, check your emails, look for this registration email. It would have come sometime over the past week or so. And I saw that probably about a third to a half of you have got that and completed your registration. And the rest of you should take a peek and maybe crank it out now. And if there are any problems, you can let us know. But I'll keep explaining stuff, and so you can either do it while I'm explaining or immediately after. But you definitely want to make sure you can get in and be able to observe. Okay, so once you get in, once you log in, you'll come to the home page. It dumps you on the home page, and then you want to go over to My Observatory and go down to Optical Observing. Now there are lots of tabs here that I have because I have management and administrator access, but you probably only see 3: Optical Observing, Radio Observing, and My Account. Under My Account, you can do things like change your password and change password, things like that. But you probably don't need to do that. Once you register, you'll have created a password. So just go to Optical Observing. And here you see a list of all the observations I've done. In fact, I have pages and pages and pages of them. When you first come here, it'll be empty. There won't be anything there because you haven't observed yet. So I'm going to show you how to observe. We're going to add a new observation. So that was over here on the right. The second one down, add a new observation. And it takes you to a page that has a little map of the sky. If you press the clock button, it takes you to right now. And right now it's daytime. In fact, the sun is just coming up. Let's see, I have it currently set for the Mars Desert Research Station. That's one of our sites in Utah. So in Utah, the sun's just coming up. I'm gonna push it along a few hours till the sun sets, and then you can see the nighttime sky. There's all sorts of things here. You can explore if you want. Like if you don't know what to observe, now the lab will tell you what to observe, but if you just want to have some fun, you can poke around and click on any of these. These with an M is something called a Messier object. They tend to be big, bright, pretty things like there's a galaxy, This one over here is a field of stars. There's another galaxy. So you can poke around the sky and it shows you different options of things you can observe. Or you can just look things up. And you see there are also planets here and moons, like there's the moon. And click on that, you won't see any picture because the moon is a moving object. The planets are moving objects. They move through the sky. So it's bringing up an old sample of this part of the sky from long ago. So the moon's not there when that was taken. But let's say I want to observe, I don't know, Jupiter. You can find it here. It's somewhere in the sky. Here it is. You can zoom in by drawing a box. Got a little cluster of planets going on. We got Jupiter, Saturn, Mars there. You can just click on Jupiter. Or you can type it here into the search, and it will find it just the same. Come down here, you can name your observation whatever you want. This one's called Jupiter. And you can modify it however you like. Jupiter is awesome. And the nice thing is you don't have to figure out the coordinates, the sky coordinates. It's called right ascension and declination. It's kind of like longitude and latitude on the globe. It looks it up for you, puts those things there. The things you may want to do, and this is explained in the video, to increase your chances of observing. You want the sun to be about 12 degrees below the horizon or more. Usually minus 18 is the default. I recommend for the labs minus 12. So the sun has to be about 12 degrees below, so it's dark enough. You want your object to be about 20 degrees above the horizon or greater. If it's too close to the horizon, you're just going to be looking through a lot of atmosphere and clouds and muck. And you want to be visible for maybe about half an hour at least to observe. Those are the three things you're going to check, minus 12, 20, and 0.5. We don't need those advanced settings. And that takes you down to this air mass chart. It shows you how high your object is. As long as it's above the gray bar for some site that you have access to. And I have access to more sites than you do, but you have access to quite a few. And it looks like for most of these sites, it's above the gray bar. That means it'll be observable sometime over the next 24 hours. Like this is now, so Jupiter's not observable now, but in 4 hours, it will be observable in whatever line that is. It's probably Australia. And then there'll be a while, and this is probably Chile. It's more observable in the southern hemisphere now, but even in the northern hemisphere, it's up for a little bit in many different sites. Okay? And next thing you do is you're going to choose your filter. Now let's just pop back to the lab for a second here, because all this stuff is given to you. Let me close out some of these accordions because it's getting messy. Like observe planets. It tells you, okay, we're going to observe these planets. It tells you which planet, what filter to use, and how long to observe. So you don't have to guess at this stuff. It's all here in the lab. Oops. That. Right here. So Jupiter, that table, it says U-band 0.1 second. U-band is, so you have all these different filters. These are the pieces of glass, the different colored pieces of glass. Jupiter's really bright, so it's recommending U-band. U is almost in the ultraviolet, not much like it to the atmosphere. We're using the atmosphere to dim it for it so we don't saturate our camera. Now, most telescopes don't have U-band, and we're short on telescopes right now. So you can do U-band, or if you go up to generic filters and select low throughput, you'll pick any telescope that has a U-band or some of these other filters that block most of the light. Jupiter is super bright, and it won't burn a hole through the camera, but it'll make it hard to observe. So maybe for us this semester.
How many days do you need it?
I'm sorry, was that a question?
I think
Okay, I think that's background noise. I muted it. All right. So a little bit different from the instructions in the video. Instead of U-band, I'd go with low through. That will increase your chance of having a telescope with that filter, given our shortage of telescopes because of COVID. You see, when I picked that, it blocked out some of the telescopes, but these other telescopes do have a low throughput filter. So I continue. Then I pick which telescopes are acceptable to me. And over here on the right, you'll have a time account, and it will list all the telescopes you have access to. If you click that orange dot, it will select all the telescopes you have access to. Like here's one in Australia, there's one in Italy, that's not on that time account. This one's in Virginia. By selecting that orange dot, you're gonna pick all the telescopes. And I recommend we do that. The lab says just select the prompt telescopes, but you know, we're so short of telescopes, I'd select anything in the system out there that has your filter. Save and continue. And then we're gonna put in the observation. And this is kind of the last bit. So all of our telescopes are different. Some are big, some are small, some are good sites, some are bad sites. And so that means each telescope needs a different exposure time to get the same result. And you don't want to have to enter a different exposure time for each telescope. So what we do is you have a design telescope. Up here, pick generic 16-inch. And it's a generic telescope that we'll design our observation on. And Skynet is smart enough to change the observation for any other telescope that it happens to be deployed on. So our filter is low through. We're going to do one exposure. And the lab said for Jupiter, 1/10 of a second. That's all it takes. You know, with a mirror that big, collecting that much light, you only need about 1/10 of a second. And when I do that, you see, if I hover over any of the other telescopes, 1/10 of a second on the design telescope corresponds to 0.45 seconds on that telescope. And some of these, it's just 0.1, but half a second on that one, 1/3 of a second on that one. So Skynet will automatically adjust the exposure time for you, so you don't have to think about that. Then you just save and continue. There's a review screen. You submit, and then it's active. There's my job, and you know, if a telescope's available right now, it will carry out that job. And I don't know if any of them are. What you could do is you can go over here to Skynet Live to see what's currently connected. And we're down to just a few telescopes, and some of them are locked, and the weather is bad in some locations. And that's a radio telescope. So the only one on at the moment is this one, and it's daytime. So it won't go through immediately, but come nighttime, as long as one of these telescopes is open, it will go through. I'll go back to my list here. Maybe I'll pick some Jupiter one that I did in the past. Here's one where I took a whole bunch of Jupiter pictures. Come on. There we go. So once you have some data back, you come here, you have a couple options. Probably the default is this. It just lists one line for each exposure. You can click on this to get a JPEG of it. And here I can see Jupiter. I can see some of the moons. And we don't get a lot of detail on Jupiter, but next week when we learn how to use Afterglow, we'll learn how to take this image and rescale it. Astronomical cameras have a lot of what we call dynamic range. You can look at the bright stuff, but not the faint stuff, or you can look at the faint stuff and not the bright stuff. So here we're looking at the faint moons. These are moons going around Jupiter, but Jupiter being brighter is saturated. But we'll learn how to adjust this so you can see clouds and the great red spot on Jupiter, but when you do that, you can't see the moons. So you can play with the image and see different things. But that brightness and contrast scaling we'll learn about next time. Really what you want to do this time is get your observations in. And since we have so few telescopes, you want to get those observations in right away. Like today, I'd put in your observations. So just to summarize which ones you're going to do. Back here in the lab, one for each planet. you don't really have to worry about Mercury. It's too close to the sun. And some of these will be too close to the sun and you won't get anything back. And that's okay. Probably half the objects are too close to the sun. The other half are far enough away. Any time of year, it's always changing. So observe the ones you can. Those are the ones where you have some line above that gray line in the air mass chart. Down here, we're going to observe moons. So basically, we're going to re-observe the gas giants, but with longer exposures and different filters that let more light through. You may saturate the planet, but you're really going to get to see the moons. And we'll figure out which moon is which and things like that. Then we have the dwarf planets. These are objects that aren't big enough to be a planet. Pluto is the best example. We used to call it a planet, but it got demoted to dwarf planet. There's some other objects out there, Haumea, Makemake, Eris out beyond Neptune, and Ceres in the asteroid belt. And so these are the recommended filters and exposures for that. And then lastly, you get to observe some deep sky objects. And we tell you to pick one of these nebula. A nebula is like a star-forming region or a star death region. And you can click on the links. I think these link to Wikipedia so you can learn more about them. Pick one of these star clusters and then pick one of these galaxies, which are really far away. And, put them into Skynet and keep checking back periodically. And if an observation is not up to your liking, there are different things that can be wrong with an observation. I'll show you that briefly in just a second. You can always resubmit. You just press the resubmit button here. If you're not happy with what you're looking at, maybe I'll go back to the thumbnail mode here. If these didn't look right, I could just resubmit and get new observations. With these planets in particular, you're burning just seconds. You've all been given half an hour of observing time, which on these telescopes at these prime observatories, people pay big money for access to these telescopes. An hour of observing goes for about $75. You've been given a half hour as part of your Webassign package. So the last thing I'll show you back in the lab is how to tell if your image is good or bad. So let's see, observe, we're observing moons, dwarf planets, deep sky objects. Here it is, how to check your images. So there are all sorts of ways an image can come back bad. It's not gonna be perfect. This is a real world thing. Or, it's a real telescope out there. You're dealing with the same stuff that the pros are dealing with. For example, if it's cloudy, you're not gonna see the stars. Instead, you see a pattern like this. You see these little circles. It's out of focus dust on the lens of the camera. So if it's cloudy, then you'll get a picture like this. You can actually see the manufacture pattern of the detector, the scraping pattern. If you get something like this, resubmit. Here's what it looks like if it's partially cloudy. You can kind of see it's a little bit blocked. You get the little donuts, but here's a clear night. If the wind is blowing really strong, it can blur your image. Sometimes the mount misbehaves and it's off-centered. Sometimes, the telescope's sitting on a rotating planet. And so the telescope has to rotate at the same rate as the planet to cancel out the planet's rotation. And if that's not working, you get streaks like this. Here it's out of focus. Here's the camera shutter breaking. These shutters are clicking constantly all night, every night, and sometimes they break and you end up getting streaks like this or an iris pattern. This is someone left the light on. This is a satellite moving through your image. Sometimes you'll capture that. This is an airplane. You can tell there are two of them. That's a light on each wing. And sometimes you actually have a bug in the system. This is a bug sitting on the camera. That's how you image the bug. Anyway, all sorts of ways it can go wrong. Most of the time it goes right, but if you encounter this, just resubmit. Okay, I think that's it for week 1. So again, I encourage you, put your observations in early and check them frequently. And hopefully we'll have some stuff back for next week. And I'll show you how to analyze the data then. I'm gonna stop my share. And if there are any questions, I'm happy to answer them.
Thank you for that. My question is for Dr. Zhang, though. Can we just log in on Tuesdays and Thursdays and do this as a class? Because this is a lot, and a lot of us are still confused.
Okay, so yeah, so we can repeat that. And also, so, I will post those videos. And here's my suggestion, okay? So watch the video, not just only one time if you can understand. If you can watch several times, you get a better understanding. And then if you request, we can have hold another Zoom meeting next week to help you. But anytime, if you have a question, just talk to me and then talk to the TA, Jacob, and we are here for help all the time, okay? But here's my suggestion, okay? Before you ask any questions, just follow the tutorial and those videos. And then watch videos first, and then ask a question. So we help you step by step, for sure. Don't worry about this. If you can spend a little bit of time to follow whatever you are asked to do, I think everything will be fine, okay? As a professor just said, so next Thursday, I will email you again for a Zoom conference, Zoom meeting for those analysis. So the first things you need to do is just follow today's what the professor showed us, and then just put those numbers, submit a request. So just one thing to do for this week. That should not be that difficult, right? So if you still have a question, how to submit, how to fill those things, let us know. We can help you step by step to do the first step. But once you submit, the waiting for next week when the data come back. So we hold another meeting to show you how to do analysis. So
okay, for our test, is it going to be on what we're doing on Webassign, or is it going to be the slides on Canvas?
okay, so I will make an announcement for the test number 1. So technically, I'll give you study guide. In the study guide, only have 100 multiple choices. I will pick up 30 multiple choices out of 100 to make the test number 1. Okay? So I will make an announcement for how to prepare for test number 1. So don't worry about this. Only like 108 multiple choices, and I'll post it online.
Our questions are coming from this, what we're learning in here?
No, don't mess with Webassign. That is the real stuff. That is in my PowerPoint notes for class.
That's in the PowerPoint notes.
Yes.
Yeah.
Class is a class. Lab is a lab. Okay. Don't worry about this. Okay. I will provide a study guide for you for sure.
Okay.
And also make an announcement. I post everything online so you can prepare for it. So 30 multiple choices, nothing more. Okay. Very good question. Okay. I will make an announcement for sure. And I will make an announcement either today or tomorrow. Okay, and then you can check all the stuff, all the materials on Canvas. I will post on that. Thank you. Is there any other questions?
Let's see. Okay. Dr. Zhang, just
yeah.
if I could take a minute to introduce myself. I'm Jake. I'm the TA with Dr. Zhang. It's been a rough year. I know exactly how confused everybody is. I had to go through this with Dr. Zhang and Dr. Reichert, learning the whole process. So I will do my best to walk everybody through it and kind of show you some shortcuts and what to concentrate on to kind of get through all the superfluous information. It's a lot to take in, but once you understand it, you'll know exactly what they're saying, and you'll be able to navigate through Skynet and Afterglow, and then it's kind of fun to play with. So if you guys want to reach out to me, I drop my number in the messages, comments. So just feel free, and I'll try and do as best I can.
Okay, Mr. Taylor. So Hannah asked Mr. Lee just now if he could do like a class with us all together, and it didn't seem like he is agreeing to it. So would it be possible for you to host a class with all of us?
On Tuesdays, Thursdays, please.
At least one, so we can get the feel of it. Because, like Dr. Dan, he did a good job at explaining, but it's still new, so we need to like go step by step together on at least one assignment, so we can be able to use it fluently.
Okay, step one, make sure you get Webassign access and Skynet logins. So make sure you have both of those set up and open. So when we walk through this, you can actually walk through it step by step with me. So concentrate on that portion of it first and getting that all set up. You know, make sure your computer saves your logins and passwords, so it's really easy to access, and you can pull it right up. After that, the video tutorials, they do help, but you have to kind of walk through them. So open up a second window and walk through them with the video, and that'll kind of help teach yourself. But yeah, we can set up a class. It's not like I'm going anywhere. I'm stuck in the house. So, any other questions?
Thank you.
Yeah.
Thank you.
And if you do that, I recommend doing it sooner. Just, you know, we want everyone to get their observations in sooner than later, because I'll be back next Thursday to, you know, introduce you to the analysis stuff. But it really helps to have some of your observations in.
Oh, yeah. And it does take a day or two to get some of these observations back. And I know we've lost some telescopes, so that just kind of backs things up even more. So if we can get it done sooner than later, then we can set up and get things moving.
And also I will postpone the deadline, extend the deadline. So far the deadline for homework 1 is April 7th. I will extend it for 1 more week. So the new deadline will be April 14th. I will change it for that on the Webassign. So you have enough time to do that. As Jacob said, from the very beginning, it's not easy. Okay? I understand it's not easy to follow from the very beginning. So that's reason many of you, not only just want to confuse that, how to step by step. But once you finish one, okay, just spend the time completing one, the rest will be a little bit much easier. So we would like to.
This is trash.
You might want to mute.
Yeah.
There we go.
So when is our final going to be? Is it going to be online?
I think the finals are most likely online, because what I understand is even for the summer courses, they put the summer courses online. So when they're not technically we meet together, because the government say we cannot get more than 10 people together. So online, the final exam like the 14 multiple choices. So the 14 multiple choices come from the test number 1 and the test number 2. Okay, so I will tell you how to prepare for that. So don't worry about the test 1, test number 2, the final exam, and just focus on do some, Webassign homework, Webassign live. Okay, so yeah, as I said, I will post all the information. So don't worry about tests. Okay, I help everybody in my class.
Thank you for helping us.
Thank you.
Let's see. I can't think of anything else. How soon would you guys want to set up class?
We can start. Well, I mean, the thing is due on Tuesday, so like at 11 a.m. So I'm not sure when other time we have to even discuss anything without it being due. So
let's see. He said he backed up the due date to the 14th.
Yeah.
Yeah.
Okay.
And he gave you an extra week, but we need to really tackle getting logins and everything taken care of. That's priority number 1. Once you have Skynet and your Webassign login taken care of, then we can get rolling.
If I can make a suggestion, try to get on. If you haven't done Webassign yet, do that right away, and then email us to make sure you have a Skynet account, and then start going through the videos and try to put in the observations before next Tuesday. And we can answer questions over email. And then on Tuesday, Does Tuesday at this time work?
Yeah.
Yes.
And maybe Tuesday, Jake can work with you, and Josh, if he's back from, you have 2 TAs, and the other one's on National Guard duty at the moment. But maybe they can help you on Tuesday. For those who are still having to take things in, and then come Thursday, I'll be back and I'll set you up for the next task. Maybe we'll hand off every Tuesday, Thursday until we get through this. That work for you, Jake?
That works for me. Yeah.
Do you know how to set up your own Zoom meeting, or should I set one up for the class? Or
I can set it up. I just don't have access to everybody in the class, so I'm short on contact.
Okay. How about this one? Email me. I can set up a Zoom meeting.
Okay.
For everybody in my class, I can do that. So that will CC you, for sure.
That's fine.
Yeah, so we're working with students step by step. Just ensure everybody can understand, everybody can follow, and everybody can complete your homework.
And we will be flexible. We'll play it by ear because of COVID-19. I don't know what telescopes we're going to have. Normally within a day or so, you get your observations back. It's a complete unknown. So let's just be patient and see what happens. We may not get the full spread of images back that we normally would. We may only get a couple, but we'll try to make the most of this experience and see what we can get out of it.
Sounds good. Any other questions?
No, I'm good.
All right. Cool.
All right.
Okay, see you guys next time. And any question, email us, okay?
Thank you.
Thank you.
All right.
Okay, thank you.
Bye-bye.
Nice to meet y'all.
Well,
Dr. Reichert, if I could.
Yeah.
On your COVID research, where were you pulling your numbers from?
Sure, I'm happy to show that stuff a little bit. Anyone's welcome to stay if they're interested. Share my screen again. Okay, so the best source of data, there are a number of sources of data out there, but this one I think is the best one. I'll share it in the chat screen just because they update like every 10 or 20 minutes. Can I access the chat screen while sharing? I'm not sure.
Is it Worldometer? Okay, 1.3 acres. Okay.
Yeah, 1.3 acres. It's anyway. So there's that link, and I'll give you a couple others. I don't know if so. I'm getting the data from there, and what I'm modeling my group. I have a small team that's modeling the doubling time. How long it takes for twice as many people to become infected. And we're not trying to model it from first principles or anything. We're just looking at the data and trying to see what's the trend. The longer it takes for this to double, the better off we're all going to be. And so this is the doubling time data. It comes right from that website. Each day I can calculate, given the number of new cases today compared to the total yesterday, what is the doubling time right now? And you can see it was increasing slowly. Then there's a bunch of data we couldn't use during the testing ramp up that messes up the measurements. But now we have some new measurements here. The doubling time is increasing, which is good. Flattening the curve means it takes longer and longer for twice as many people to become infected. And so all we're doing is fitting that empirically, and then we extrapolate, saying, if we stay on the current trajectory, what does this imply in terms of how many people will be infected at peak and overall and deaths and things like that? And the point isn't to make a correct prediction, it's to let people know, okay, given the social distancing we've been practicing, we're now on this trajectory. Is it good enough? What, if this trajectory holds, what does that imply?
Yeah.
Model it from first principles is nearly impossible. There's a zillion different factors.
Yeah, I've been tracking the R naught values and
it's essentially the same thing as doubling time and R naught.
Yeah. So like originally, I think it was around 1.4 which was similar to H1N1. So I kind of projected out, the 60.2 million or 60.8 million that they had, confirmed cases from last year. So I used that number and kind of got some mortality ratios and things like that. And it freaks people out, and I don't think they understand it. So it's just kind of, I don't know. I was trying to get your take on it. And you're doing the same thing I'm doing.
Yeah.
And,
I'm doing exponential population modeling based on the doubling time, which is empirical. So I don't have to, try to guess at what this measure or that measure will do. I just say, well, whatever is going on, this is the aggregate effect. And if it continues, what happens? And you can scroll down and you see the doubling time's now 5 days, and it's increasing by about 4 hours each day. And is that good enough? The answer is not really. We need to do better. And now I've factored in things like the asymptomatic population. It seems that for every person who shows symptoms, there are 2 people out there who never show symptoms, but they're still carrying it and spreading it. And we didn't know about them because we're only testing the sick, the symptomatic. But Iceland is testing everyone randomly, and they have found that it's 2 to 3 times as many people out there. They're just unknown carriers. They don't even know they're doing it. So that's built into the model now, and it has a couple effects. It makes the peak happen sooner, but actually fewer people get sick in the long run because you develop herd immunity quicker.
Yeah, I was wondering what that, how that was going to play into it. So that answers that. That's cool.
Yeah.
I'll definitely have to run through the data that you have.
Yeah, and so here are the numbers we're getting in terms of this is just for America, the number per day infected at peak, the number reported, which is about a third of the total, when the peak will be, what fraction of the population will get it, what fraction will show symptoms, and then the death rate and total deaths, which is still a very scary number. But again, this is not what we're saying will happen. It's what will happen if we stay on the same trajectory. Hopefully it gets better. Yeah. It's meant to be kind of empowering. We're all working, trying to do this social distancing, and then you can come here and see what is the effect of that.
A lot of it has to do with people can't really stockpile for long enough to stay away.
That's right. That's right. We have to. I actually broke down and I'm building a garden in a picture garden. Like in World War II?
This was last week's project.
Yeah, show me.
So we did this one and then this one. So we're on the train.
I like here. I'm putting up I did a swath of land, 25 feet by 25 feet, and I'm putting up a fence so the deer don't eat it. So I've been doing post-hole digging and sledgehammering and using muscles that I never use. And I spend my day behind a computer using these are the muscles and this. So I'm feeling it today, but I'm making progress.
Yeah, our HOA wouldn't be happy with us doing that, so this was as far as we could get with it. But
the other thing I'll say about the site is we do a daily report, and I post on my Facebook site too. And if anyone wants to follow me on Facebook, I accept all friend requests, and then I unfollow so I don't actually follow you all because that would overwhelm me. But every night we do an update explaining a little bit more about the model, updates. Like last night, this may interest you, the topic that my group had been discussing is the death rate, which is a topic I normally don't want to post about because I don't want to scare people. But the way people calculate the death rate is the number of people who have died divided by the number of people who are infected. But that's actually not right because there's a time delay between being diagnosed and for those who will die actually dying. So you're supposed to take the number who die and divide by the number who were infected a few days ago. But since this is exponential growth, most of the people who are infected have been infected just over the past few days. So it actually boosts the number a lot more than, people are reporting like 1.5%. It's closer to 3.5%.
I just crunched it a minute ago and it gave me 5.
Okay.
Just,
It really depends on the delay that you choose.
yeah. So I'm basing that off the worldometer numbers that I pulled off.
And of course, if you exceed the healthcare capacity, that number is going to skyrocket.
Yeah, that's what happened in Italy.
Yeah.
So yeah, their numbers are just crazy.
Scary. It's like 9% last I checked, and it's probably higher now.
Yeah, it's probably 11 or 12. But that's just wow.
Yeah. These are scary times, and so I hope everyone's taking social distancing. It's basically all we can do. Take it as seriously as possible. If you have a mask, I would recommend wearing it, despite what we've been told.
Yeah. Oh yeah, we've made our own.
Yeah.
Let's see. They're trying to figure out how to purchase the Webassign because the bookstores. Hold on. Pull that up again.
Yeah, this is something we've been running into at a couple institutions. Normally, you'd buy it from the bookstore with financial aid money if you have it.
Yeah, bookstores said they don't have an access code. It's purchased directly from the site, correct?
You can purchase directly from the site with credit card or debit card, but that's your own money.
Okay.
If you want to spend financial aid money, you get through the bookstore. Dr. Zhang, you got these things into the bookstore, right?
Which way in the bookstore?
The Webassign access cards. Does
Yeah,
the bookstore have
because I talked to the bookstore people 2 weeks ago, and then what they told me that 3 weeks ago, and then the financial aid they already refund to the students at the time. So that is the problem because after 1 month after such a day, so the financial aid they will refund to the students, but the students still can purchase on the bookstore. And then here is I suggest them purchase online also. But I hope still somebody will purchase for sure for the Webassign, and we set up a Skynet Aftergroup account for them continually, and I hope so. But for those eventually cannot make a Webassign, I still think about figure a way, and to help them a little bit. So this is what I'm trying to do.
Okay.
Okay.
Any other?
Okay, so
I think that's it.
Okay.
yeah, that's it. See you guys next time.
Well, good luck to y'all on Tuesday, and I'll see you on Thursday. And I'll share this
Thank you so much. Thank you.
with the two of you, and you can distribute to the students.
Yeah. Bye-bye. Thank you. Bye.
Bye, Dr. Zhang. Bye, Dr. Reichert.
See ya.